Now that we've learned the truth tables for the negation, the conjunction, and the disjunction, we will consider now the truth tables for our other two connectives, the conditional and biconditional, here in section 3.4. Let's start with the conditional truth table. Now, let me remind you that a conditional statement is a statement of the form if P, then Q. We can denote it P arrow Q, or another way to read it, P implies Q. This is a one-way street from hypothesis P to conclusion Q. Now, the rules for the conditional truth table can be a little bit confusing. So before we talk about those rules, we're going to examine an actual conditional to get a better intuitive understanding of how these rules work. Now, before we jump into this example, let me give you a little bit of background. My husband, Mark Cornell, is a sports performance trainer. He owns a gym and he also trains our police recruits over on the West campus of Amarillo College. Now, back in the day, many years ago, he used to teach a racquetball class on the Washington Street campus. And in his syllabus for that particular class, he always challenged his students and he said, if you beat me at a game of racquetball, then you get an automatic A for the semester. Many students challenged him over the years, but no one was able to beat him at racquetball and get that automatic A. But it was always exciting. Sometimes he would play left-handed to give them an advantage. But the idea here is that he had this conditional statement in his syllabus. If you beat me, Coach Mark, at racquetball, then you get an automatic A in his class. So we have two statements. You beat Coach Mark at racquetball. We're going to call that statement P. And you get an automatic A in his class. We're going to call that statement Q. So because we have the connective if then, this is a conditional that can be written in the form if P, then Q. Now, because we have two simple statements here, we would need a 4-row truth table, and that's what we have down here below the example. So we're going to build it like we do all 4-row truth tables. We're going to look at 2 T's and 2 F's for P in column 1, and then we'll alternate true and false for Q in column 2. Now, our goal is to judge the truth value of this conditional, but we're going to think about reality before we make that call. Let's think about each individual component of that conditional. So looking at row 1, we are going to assume that P is true. Remember, P is the statement you beat Coach Mark at racquetball. If P is true, then yes, you beat Mark at racquetball. That's awesome, right? Now, next question. Did you get an automatic A? Well, remember, statement Q is you get an automatic A in his class. Looking at row 1, if Q is true, then yes, you got an automatic A. So here's reality. You beat Mark at a game of racquetball, and he awards you an automatic A. Did the conditional in his syllabus, was it true? If you beat me, then you get an automatic A. Yes, he told the truth. Therefore, the conditional, if P, then Q, is true. Okay, let's look at the next set of conditions. This time, we're going to figure out what happens if P is true and Q is false. So if P is true, then you really do beat Mark at racquetball. If Q is false, the statement you get an automatic A in my class, if that's false, then that means no, you did not get an automatic A. So here's what happens. You beat Mark at a game of racquetball, but he does not award you an automatic A. You'd be really mad, right? You'd say, I got robbed. Did he tell the truth? No, he made a promise and he didn't follow through with it. So our conditional statement would then be false. So far, so good? Okay, let's look at another set of conditions. Looking at row 3 here, we're going to assume that P is false and Q is true. If P is false, then that means you did not beat Mark at racquetball. You gave it a shot, didn't cut it, right? So no, you did not beat Mark at racquetball. let's suppose that Q is true. If Q is true, then you get an automatic A in the class. That's pretty exciting. You didn't beat Mark at racquetball, but he awarded you an automatic A. Not for the reason that you beat him at racquetball, but for some other reason, right? Did Mark tell the truth in his syllabus? If you beat me at racquetball, then you got an automatic A. You know what? He did. This is just kind of a special case. You didn't beat him, but he gives you an automatic A for some reason. The conditional statement that he posted in his syllabus is still a true statement. Let's look at the next one. In this case, we're assuming that P is false. So if P is false, did you beat Mark at racquetball? Nope. We're also assuming that Q is false. Did you get an automatic A in his class? No. Well, let's consider, did Mark tell the truth? So you, like many other students, attempt to beat Mark at racquetball and you don't beat him, and you end up not getting an automatic A. You just have to receive the grade that you earned, right? Well, what about the statement in his syllabus? Is it still a true statement? Yes, it is still a true statement. So his conditional statement is true. Now, if I could take this truth table and delete everything in the middle and look at the first two columns and the last column, that's essentially the truth table for a conditional statement. The part that is usually most challenging is this case right here. So think about that. Think about reality, what happened there, and how we made the conclusion that the conditional was true. That one is one way to look at it. Is true by default. You didn't beat Mark, you got an automatic A anyway. The conditional statement is still true. So let's attempt to summarize this truth table in a single rule. Here it is. A conditional is false. Did you notice that's the only one that really stands out? Every other time it's true. So that's the one I want to focus on. A conditional is false when the hypothesis P is true and the conclusion Q is false. That is, true implies false is false. That's a great and concise way to memorize this particular rule. So let's condense this into a single truth table that you can memorize. Filling out our truth table in the usual way, we'll start out with 2 T's and 2 F's, alternate T and F in the next column. Then the rule for the conditional is it's only going to be false if true implies false. So reading from hypothesis to conditional, because this is a one-way street, true implies true is true. True implies false, that's the only time it's false. False implies true is true. And false implies false is true. Now, don't let your brain say double negative and conclude that one to be true. It's a little different because we're looking at a conditional. So take some time and let that sink in. Make sure you know how to summarize that truth table in the single rule and memorize this truth table. In the next video, we'll look at the biconditional.